Solar panels, or solar voltaics, are flat panels that can get energy from sunlight. How exactly do these things get energy from the sun? Solar cells use two competing forces to move electrons around. Moving electrons is what electricity is. The first force is the force provided by electric charge. Electrons are negative, so other negative charges repel them while positive charges attract them. The second force is the tendency towards complete electron shells. Electron orbitals and shells are in their lowest energy states when full or empty, not when half full or half empty. Silicon, the element under carbon in the periodic table, acts similar to carbon in the fact that it can bond to four other atoms to complete or empty its electron shell. Pure silicon is able to bond to itself and make perfect complete shells. This perfection is unable to get energy. We need to introduce some instability. This instability can be introduced by replacing some silicon atoms with other atoms, a process known as doping. For solar voltaics, two types of this impure silicon are used. N-type silicon is silicon that has been doped with phosphorus. Phosphorus has one more electron in its outer shell than silicon, but because the silicon grid is equipped for 4 electrons and 4 spaces, the fifth electron of phosphorus has nowhere to go, so it creates dissonance. On the other hand is p-type silicon. This silicon has been doped with boron. Boron has one less electron in its outer shell than silicon. This creates an electron hole, or vacancy, that really wants to be filled. In a solar panel, these two layers are sandwiched together, n-type over p-type. In the middle, the extra electrons from the n-type layer move into the holes of the p-type layer. While this solves the imbalance in electron shells, it creates a new imbalance, an electric field. The n-type layer has lost electrons, but not protons, so that makes it positive. The p-type layer has gained electrons, but not protons, so that makes it negative. Now, when the photons from the sun strike the voltaic, they might hit some electrons within the exposed n-type layer. When an electron is hit, it gains energy and leaves the silicon layer for a conductor that carries it off to be electricity. Meanwhile, the electron vacancies mean that both the tendency towards complete electron shells and the electric charge are telling the electrons to move from the p-type layer to the n-type layer. This puts the electron vacancies back into the p-type layer. At the same time, the electrons being used for electricity are brought back into the p-type layer to start the cycle over. All in all, solar cells are systems that take in the energy of sunlight and output electricity. They are able to be used repeatedly because they bring electrons back around to repeat the cycle. They are a useful clean energy source that is also renewable, and their workings are pretty interesting.